in this video, we're going to continue topic 8.3, and we're going to look at example 1C. So at 8 p.m., volunteers began to process the entries. They processed the entries at a rate modeled by the function p, where p of t equals t cubed minus 30t squared plus 298t minus 976 hundreds of entries per hour for between when t is between 8 and 12. According to the model, how many entries had not yet been processed by midnight at t equals 12? So what you've got to start out with is we got to start with how many entries they actually got, which was measured right here. So I'm starting with that initial condition at 8. We know we had 23, and that was represented in hundreds of entries. So that's where I'm going to start, is writing 23. And then I'm going to subtract what they process. So I'm going to process this interval on my integration from 8 to 12 of this new equation, p of t dt. So I would need to write that down to actually get my points on my AP test. So I'm going to use, I have the power of being able to use the technology on this one. So I'm going to use my calculator. I already typed in p of t, and I'm going to do 23 minus the integral from 8 to 12 of p of t, oops, in parentheses, not in subscript, p of t, and if I put the dt, notice I just got a 7 right there. So that's all I would have to write down to finish this off. So it'd be 7, and I would want to label it 100 or 700 entries. All right, let's take a look at D. So according to the model from part C, at what time were the entries being processed most quickly? And we are supposed to justify our answer. So when we're talking about most quickly, that's going to be some kind of a maximum value. So that means I'm going to need to do a t-chart of some kind. So I will try to squeeze in here. So I know I need t, I know I need p of t. I'm going to have to figure out where I have candidates. So I know that I need to look at where p prime of t equals 0. I need to figure out what times that actually happens at. So I'm going to go back to my calculator. I'm going to look at this graph. And actually, I probably want to look at the derivative of that graph. So I'm going to draw my derivative. I'm just going to go p prime of t. Actually, I need to say y equals that, and then it will graph it for me. There it is. And I'm going to limit this because we're only supposed to be between 8 and 12. So I'm going to change my axis to x equals 8 and to 12. Okay. And then I'm also going to turn off my red graph so it doesn't confuse me at all. So I am noticing that we're going to be between 8.184 and between 10.816. Now, Desmos isn't giving me a really great estimate on that. I really should have more decimal places, so it's better to probably use your graphing calculator. I'm going to use, in my example, I'm going to use one more decimal place for the calculation probably, just so you get the accurate numbers in your example here. So I am going to put in, it was just like off by just a little bit. So it's at 9.1835, which would round to what they had. And the other value was at 10.8165. So a little bit further out. So I know I have to test my endpoints, 8 and 12, and then I have to use my candidates in the middle. So 9.1835 and 10.8165. So now I need to take this and I need to plug it into my original P, and I'm going to use my calculator to do that again. So I'm going to go back here and I'm going to say, and I want my original P. So I want P of 0, no, not P of 0. I want P of 8. All right. And then I want P, and I'm going to use the decimal point that we wrote down instead of the one that we calculated on the graph, 1.835. That gave me, it's in Desmos, you get the, if you use the left side for the calculator, you get more accurate. And then 10.8165. For my test, if you do use the values that were on here in Desmos, I would accept your answer. And then P of 12. So I'm going to write all those values down. I'm probably only going to write the 3 decimal places in my chart. So I've got 0, and I've got 5.089, and I've got 2.911, and I've got 8. So let's go back and read what it wants us to do. According to the model from part C, at what time were the entries processed most quickly? So I'm looking for the maximum. It looks like my maximum was at t equals 12. So, and they were specifically looking for what time they were being processed most quickly. So I'm going to write a concluding sentence on that. So the entries I totally, oh yeah, I did spell, no, I didn't spell right. There's no RE there. Are being processed most quickly at t equals 12 hours. So I just was quickly skimming this. So this topic revisits an idea that was previously introduced back in Unit 6 with the topic 6.4. Because it's consistent presence on the AP Calculus exam, we're examining it again. Previous example along that one follows both come from the 2010 operational exam, and they illustrate various applications of the definite integral and accumulation functions as well.